Hey, this is Mike from Minimal 3DP, and today I'm taking a look at my Creality K2 Plus and optimizing the bed leveling in the heated chamber. So let's go ahead and get started. Last year, in playing around with my Creality K2 Plus, I started printing a lot more with ASA. And one of the problems I found with ASA or any of the filaments that require the heated chamber is the fact that the heated chamber on the Creality K2 Plus takes forever to heat up. Just a quick search and you can find that there's a bunch of mods out there to basically heat things quicker. Here's different posts about people basically complaining about how long it takes. This one user is pointing out to get to 60 degrees, it took 45 minutes. And that's pretty intense. Getting some Facebook posts about the same issue, different mods and suggestions on how you can speed things up, and also some other ways to make changes. Now, what I've done is put together a set of scripts for myself that I use, that these are set up to help optimize how fast things heat up. If I look at my script, I have some custom start code. And one of the things I do is I heat the bed up. So the bed, it gets hot. Then I heat the chamber and use both of those together to speed things along. I also make sure the fan is set to 0. Now this only does that if I'm using ABS or ASA. Starting pretty much yesterday, I've updated these scripts. And the update I've implemented is, one, there's now a heat bump of 5 degrees when you're using ABS or ASA, the goal being to help get that chamber as hot as possible, as quickly as possible. And I found that I've had pretty good luck with getting this heated the way I need it. The other change I've done is I finally got adaptive bed mesh to work for me. Now, this was a long time in coming. It's taken me forever to get to this point. And I need to point out these scripts are all used at your own risk. But for me, they've been working, and I now have adaptive bed mesh. And what I've done is set this up so you can pass in the start script a adaptive equal 1, and that will then do the adaptive bed mesh calibration. Now, if we go over, I have a sample of the start code you need to use, and I'm going to point out I did get at least these 3 lines here. I used AI to help me with those. Now, those lines are commented out, but there was an interesting thing I discovered where when I started my print, it would start and actually heat up to my printing temperature, which is about 240 or 260 when it comes to ASA. And then it would need to cool down to do the bed leveling. And AI suggested that I put in these 3 lines and just comment them out. And for some reason, OrcaSlicer will then not heat things up to that initial temperature till after it's done the bed mesh. And I'll be honest, this is working, and I'm still a little confused as to why, but these lines are commented out. So you'll need to put this in your start code for OrcaSlicer. Nothing else is changing here. And then you'll also need to, and let me go over here, you'll also need to add the m3dp.config file to your printer, and you'll also need to update the printer.config. Let's go over and take a look. So I've opened up Fluid on my machine, and you do that via going to the IP address :4408. Go down here to configuration, and as you can see, I've uploaded the m3dp.config file. And then over in printer.config, there's a couple changes. We need to do the include m3dp.config. Scroll down here. We need to turn force leveling to false. Scroll down, and this gets all the way towards the bottom here. We're going to keep going, and we're looking for the bed mesh. And in the bed mesh, and let me find it here, somewhere here. Down in bed mesh, we need to change the probe count to 5 by 5. And then up here in the PR touch underscore V3, we need to change the enable not linear comp to false. And this is basically, you're using this to stop it from erroring out based on sending the new code. Now, I found this all works. And so once I have all this loaded, and I've added the start code over here on my printer under machine G code, updated the start G code here, I'm then ready to print. So what we're going to do is I'm going to pause for a minute and set up the camera, and I'm going to send these print in place animals, and this is a little elephant model. Now, I don't know where I got this. I wish I had documented that, but I saved this model over a year ago, and I just have it on my local machine. So I'm going to print this model, and you'll see that it does not probe the whole bed. Now, I still think it can be quicker, and I'm working on that, but at least right now it's only probing a small area. And then once it's done probing, it'll actually start printing the model. So we'll take a look, and let me switch over to the camera, and we'll take a look at it as it prints. Now, to start out, I'm just going to send the model to the printer. Now, I have made sure that no calibration is turned on the printer. Now, this is giving me an issue here with the model, and this has to do with the elephant's ears. We can ignore that. I'm going to go over and just make sure that the file actually arrived on the printer. It started to print now. Now, I'll come back in a minute once we're starting on the bed level. Now, the way I have this set up, you'll notice in the little window in the top left corner is this is heating to 140 to reduce ooze from the nozzle. And then it's heating the bed to 55, which is my print temperature. So you'll notice that the printer is now probing. And it is doing the spiral pattern. And it's doing a 5 by 5 grid. This will take a minute to complete. But as you can see, it is doing that center of the bed. I'm also going to point out while we're watching this that one of the things I'm doing is printing print-in-place models. And I do STEM outreach as part of my job, and I give those models to kids. If you ever want something rewarding, print some cool models, particularly the little print-in-place, and just give them out. And particularly kids, you want to get them, at least for me, I want to get them interested in science, technology, engineering, and math. That's a lot of good paying jobs, particularly being from a rural community. It's again something where somebody can make a really good living. And for me, it's just plain fun. But as you can see, the printer only probed the center of the bed where my elephant models are going to be. I'm just going to let it print out. And I can tell you already, the model quality is going to come out well. We've already printed one. And I want to thank you for your time. I hope you have a great day. If you have any questions or comments, please post them below. Additionally, if you have any ideas on how to improve my scripts, I'd love to hear it. So thanks. Have a good day.